Hello, you're listening to the Science of Everything podcast, episode 87, The Geography of Earth. I'm your host, James Fodor. Now, in this episode, we are going to look at some of the major geographical features and aspects of the planet Earth. This episode, in a sense, is going to serve as an introduction to a future series of episodes that I'm going to do covering other aspects of geography, including climate systems, weather, and the atmosphere, and so forth. But in this episode, what I want to do is sort of set the groundwork by talking about some major aspects of the geographic features of Earth. What we'll look at in this episode will include, I'll talk a bit about the continents and the concept of a continent. I'll talk about geographic zones and climactic zones, and I'll talk about some of the major mountain systems and river systems on Earth to sort of set a bit of a landscape for the types of features that are relevant for study of the planet Earth. And then we'll conclude by talking about some of the major biomes found throughout Earth. These are basically areas with common flora and fauna and similar climates. So this episode will be largely descriptive, that is, we'll describe a lot of features of the Earth rather than explain why they are that way. In future episodes, when we look at some of the more underlying processes, we'll talk about some of the reasons why things are this way. But I thought it would be good to set up the stage, so to speak, with just a sort of a descriptive introduction of the geography of Earth. So obviously, this is a large topic, so I'm going to be talking at a fairly coarse scale, so a lot of the details will necessarily be omitted. Nevertheless, I think this is a useful exercise. So, all that being said, let's begin, and we'll start by talking about the notion of a continent, because whenever you begin with the study of the geography of Earth, you always start by talking about the continents. So, a continent is understood to be a large, continuous, discrete mass of land separated from each other, separated from other continents, by large expanses of water. That is not a precise definition, and indeed, continent does not have a precise geographic or geological definition, particularly because of the idea that a continent is a large area of land. I mean, how large is large? The cutoff that's typically drawn is that Australia is said to be the largest continent. It is 7.6 million square kilometres in area, whereas Greenland, at 2.16 million square kilometres, is said to be the largest island. So there's a fairly big difference in the size of Greenland and Australia, but no real reason as to why one's a continent and the other is an island. It's just an arbitrary measure, really. But there are some other points of contention about the number of continents. So the only two continents that truly fit the definition of a continent, that is, a large body of land separated from other continents by an expanse of water, are Australia and Antarctica. Antarctica, by the way, is covered in ice and snow, but there is a landmass underneath there, whereas in the north, at the North Pole, up in the Arctic Circle, there is no continent there. There is no landmass underneath the North Pole. So that's why Antarctica is a continent, but the Arctic, or the Arctic Ocean or whatever, is not a continent because there's no land up there. But in terms of the other continents, it really depends on how you want to carve things up. So there are different conventions about how to define the other continents. One convention is so-called the Seven Continent Convention, which treats, in addition to Australia and Antarctica, Africa, Europe, Asia, and North and South America as separate continents. North and South America, however, are joined by a land bridge in Panama. And according to the convention that splits them into two continents, usually the divide between the continents is taken along the Isthmus of Panama, where it's sort of thinnest, on the basis that although they are linked by a land bridge, it's very narrow compared to the size of the land masses, and so it sort of makes sense to separate them geographically. A similar principle is used with Africa, which is connected to Asia through the Gulf of Suez, or around that area, essentially where the Suez Canal is today. And again, that's a very thin land bridge compared to the size of the two continents, but technically there is still a connection there. Another convention is to combine the Americas, North and South America, into a single continent. So there's the Americas, and then Europe, Asia, Africa, Australia, and Antarctica. Probably the most difficult separation to make in terms of continental divides is that between Europe and Asia. So I've talked about the distinction of North and South America and Africa, and obviously Australia and Antarctica are islands. But how exactly do you split Europe and Asia? Well, The normal convention these days is to say that the Arabian Peninsula, Turkey, and everything east of that is all part of Asia, and the sort of peninsula bit that sticks out in the northwest of that large landmass is Europe, and the dividing line up in the north between Europe and Asia is usually taken to be along the Ural Mountains, which are in Russia. So by that definition, most of Russia in terms of area is in Asia, but then there's a substantial part in the west, which is European Russia. But this convention has changed historically, and at different times in history, different rivers and other demarcations points have been used, because there's no real obvious geographic divide between Europe and Asia in the way that there is with, say, the Isthmus of Panama or the land bridge above the Suez Canal separating Africa from Asia. The actual reason why Asia is classed as a continent dates back to really ancient times, when the Greeks started to classify the different regions of the world. And of course, they didn't know anything about the Americas or Antarctica or Australia. So for them, they divided the world into three: Africa, Europe, and Asia. To understand why, you have to sort of shrink your scope of the world down to focus really on the Mediterranean area, centering around Greece and later Italy, where these classification systems developed. If you look from the perspective of Greece, and again shrinking your point of view so that you're only considering a sort of circle around that area of the Eastern Mediterranean, the land naturally divides itself into sort of three groups. On the one hand, there is what we call Europe. This is to the northwest of the Aegean and the Black Seas. To the south of the Mediterranean is another large landmass, which is bordered by the Mediterranean at the north and the Red Sea on the east. This is what we call Africa. And then everything to the north of the Red Sea and to the east of the Aegean, Black Sea, and the Mediterranean, all of that was what they called Asia. So from that perspective, this three-way division made a lot of sense. There were distinct peoples and distinct climates and other factors that were relevant in Africa versus Asia versus Europe from the perspective of the Greeks and even later the Romans. As time passed and more was learnt about the geography of these regions, it became clear that in particular there was a large landmass, essentially what we now call Russia, which joined up Asia and Europe to the north. Now this was an area that the Greeks and even the Italians or the Romans didn't really have much interest in or knowledge of, and so it sort of wasn't relevant to their classification system. But nevertheless, the Greek and the Roman knowledge was sort of codified and then developed through the early Middle Ages and through the medieval period, and sort of refined into this form called a TO map. That's capital T, capital O map. And I'd recommend looking this up. I'll post an image of one on the Facebook page. This was how the world was typically represented in Europe in the Middle Ages. Around the edge was the Great Ocean, the World Ocean, which was thought to sort of surround all of the continents. And Asia was usually put up occupying the top half of the circle. And then at the bottom half of the circle was divided into two: Europe on the bottom left and Africa on the bottom right. Europe being divided from Asia by the Aegean and Black Seas, and from Africa by the Mediterranean Sea, and then Africa separated from Europe by the Mediterranean Sea and from Asia by the Nile and the Red Seas. Jerusalem was marked at the center of the map, and east was usually put as north, because essentially that's the direction that the sun rises, and so that's sort of the natural way, at least according to the way they thought of it, of orienting the map. It's a very different worldview than we have now. We don't think of Jerusalem as the center of the world anymore, which they did for cultural and religious reasons. We now orient maps to the north rather than to the east, and we're more interested in a precise cartographically accurate map of the coastlines and so on, which wasn't as important back then. So anyway, this little excursus has been to explain why it is that Europe and Asia are typically divided into separate continents. It's for historical reasons, basically, historical, political, cultural reasons. If you sort of started from fresh and just divided up the world today into sort of obviously separate regions, I think it would be reasonable to classify North and South America as separate continents and Africa as a separate continent, but the Europe and Asia would be combined together in a large continent called Eurasia. That is another classification system of continents, one that has Eurasia, Africa, North and South America, Australia, and Antarctica. Of course, you can just combine the Americas together and Europe and Asia together. So then you'd have the Americas, Eurasia, Africa, Australia, and Antarctica, and that'd be a 5-continent. And some people even go to the next stage again and combine Africa, Europe, and Asia together to form something called Afro-Eurasia. But at this point, it's sort of just becoming an issue of semantics about how you classify things. What I really wanted to get across with this discussion here is, first of all, that the way we classify continents is sort of historically and culturally contingent, and secondly, there is no generally agreed upon definition of exactly what a continent is. Also, a final point before we move on, continents in this discussion are sort of a cultural or partly geographic unit, and they're distinct from continental plates, which are a concept in geology and which relate to the tectonics of the Earth's crust, and that we'll come to in a later episode. So these two concepts are distinct. Okay, so moving on from the concept of a continent, and now I want to start talking about the idea of a geographic zone. And this will lead us later into our discussion about biomes. So once again, the idea of a geographic zone dates back to the ancient Greeks, including a scholar by the name of Parmenides, and also later with ideas developed by Aristotle. So both of them and others around the time discussed the division of Earth into different regions based on differences in climate, and they discussed this in terms of the distance from the Earth's equator. Now, an important thing to understand is that since at least the time of the ancient Greeks, and probably before that, educated people have known that the Earth is round. There's a pervasive myth that people, even in the Middle Ages, thought that the Earth was flat. That's not true. Uneducated people may have thought that, but educated people for thousands of years have known that the Earth is round. They did not, however, know about the existence of the Americas, or really anything about the Southern Hemisphere. They really only knew about what we would call Africa, Europe, and Asia. So, from the ancient Greek perspective, they thought of the world as surrounded by a world ocean, with, as I mentioned, Europe, Asia, and Africa are all separated by the various seas. With respect to geographic zones, what Parmenides and Aristotle did was essentially divide the climactic regions up into 3, based on distance from the equator. The way Aristotle described it was in a 3-way division between what he called the frigid zone, the temperate zone, and the torrid zone. The torrid zone we would today call the tropics, and these were hot regions. The temperate zone is between the torrid and the frigid zones, and this is an area of relatively mild temperatures. The frigid or polar regions are cold, and they're far to the north. So this was how the ancient Greeks viewed the world, essentially. Far north was cold, far south was hot, and in between was just right. And of course that's where the Greeks lived, although it is also where many other civilizations lived too. Now, this is a very simplistic way of viewing geographic regions, but it's still fairly similar, just at a much coarser level of analysis, to some of the geographic and climactic divisions used today. In particular, we still use the demarcation between what were known as the frigid, temperate, and torrid zones. These still appear on maps as the Tropics of Cancer, the Tropics of Capricorn, and the Arctic and Antarctic circles. There's obviously much more that can be said about climate classifications. A more modern climate classification scheme is called the Köppen climate classification scheme, and it divides up the world into sort of 5 major categories: tropical, arid, temperate, cold or continental, and polar, and then there's sort of subcategories within those. We're not going to go in detail through those, but I will come back later in this episode to talk about major biomes. And biomes are defined more by the types of life that exist there, so plants and animals, but they correlate strongly in many cases with the climactic regions. So we'll revisit this point shortly. But before we get there, I want also to talk about some of the major mountain ranges and rivers in the world, because they set the stage for a lot of the other sort of detailed local geographic features, many of which are determined in relation to large mountains and river basins. So a mountain range is a geographic area containing numerous geologically related mountains. So it's not just where there are lots of mountains, but a mountain range has to be mountains that are related to each other, and in a sense formed through the same or similar processes around the same sort of time. Most mountain ranges are formed through the operation of plate tectonics, which we'll talk about in a future episode. Although there are many mountain ranges on the planet Earth, being a large place. You would expect that, and it's also quite a geologically active planet, so again you would expect the formation of mountains on a regular basis. But perhaps surprisingly, the majority of the mountain ranges, or at least the larger mountain ranges that exist, are actually part of one of two large belts, mountain range belts that exist, that sort of wrap around the globe. Either the Pacific Ring of Fire or the Alpide Belt. The Pacific Ring of Fire largely is defined by the boundaries between tectonic plates. So it lies essentially around the Pacific, along the coasts of North and South America, and then down along around Japan, the Philippines, and Indonesia, loosely speaking. Because of the activity of the plates moving relative to each other, or towards each other, away from each other, and so on. Again, it processes that we'll talk about when I do an episode on plate tectonics. But as a result of these processes, mountain belts, mountain ranges are formed pretty much all along the edges of the Pacific Ring of Fire. It's called the Ring of Fire, by the way, because there's also a lot of volcanic activity along those regions. But here we're talking about just the mountains, and we'll talk about volcanoes another time. But the Pacific Ring of Fire includes the Andes of South America, which is often thought to be the longest single mountain range on Earth. It extends pretty much right up the west coast of South America. It also includes some mountains along the North American coast, Pacific coast, the Aleutian Mountain Range, on through various mountain ranges in Japan, Taiwan, and the Philippines, and down through Papua New Guinea and New Zealand. The other major belt of mountain ranges includes many of the mountains along Indonesia, runs through the Himalayas, ending in the Alps in Central Europe and in Spain, and also the Atlas Mountains, mountain ranges of North Africa. Oh, the Alpine Belt also runs through the Zagros Mountains in Iran. So quite a number of the mountain ranges throughout the world can be understood as being part of these large belts that are a product of tectonic plate activity, which, again, we'll get to in another episode. But there are some other important mountain ranges as well that are not part of these, including the Ural Mountains, which I mentioned before, that are often taken to be mark the divide between Europe and Asia. Well, that's kind of arbitrary, but still a very important mountain chain. The Appalachian Mountains in the eastern United States, the Great Dividing Range Mountains in eastern Australia, the Kunlun mountain range, which marks the northern border of the Tibetan plateau, which is bounded in the south by the Himalayas. That's a very high region of the world, surrounded by two very large mountain ranges. A related mountain chain to the Kunlun chain is also the Altai Mountains, which are also in Central Asia, but sort of extend northwards from the edge of the Himalayas and the Kunlun Mountains up towards the Gobi Desert. There's a lot of mountainous areas around the Central Asia regions. The Rocky Mountains, obviously, in sort of central western United States. Another significant mountain chain in Europe are the Carpathian Mountains. So many people have heard of the Alps around sort of Switzerland, northern Italy. Carpathian Mountains are more in Eastern Europe, what we today call Slovakia, Hungary, Romania. So these are just a few of the larger mountain chains that you find around the planet Earth. Of course, there are many more as well that I could have talked about. There are a bunch more in sort of Russia and Siberia that people don't know as much about because they're away from populated areas, but are quite large as well. And also a very large mountain chain across Antarctica, which also for obvious reasons is not particularly well known. But enough on mountains, let's talk a bit about rivers. And particularly I want to focus on river drainage basins. A river basin or a drainage basin is an area of land where all the water ultimately flows to a common sink point or a common end point. Usually this end point where the water ends up is the ocean or one of the oceans, but sometimes it's an inland sea or a dry lake, or it can be also just groundwater. Water can be lost to the groundwater into the water table. But the reason these are important is because within a large river basin or drainage basin, all of the small rivers and streams and tributaries ultimately converge onto one large river, which then flows out generally to meet the ocean somewhere. And so all of the river systems in that area can be said to be linked, and often there's a large dependence upon that particular water source, or drainage source in that region. And so understanding the major river basins of the world is very important to understanding things like ecosystems and animal habitats, but also crop irrigation and patterns of human settlement. All sorts of things are dependent historically and contemporarily on river basins. So when talking about river basins, the place to start is always the Amazon. The Amazon River is not necessarily the longest river in the world. It sort of vies with that with the Nile. Many people think of the Nile as the longest river. It really depends on exactly where you define the source of the river as, because these both start up in sort of high mountain areas where the sort of first trickles of the rainfall or the precipitation combines together to then eventually far downhill form the river proper. So it's kind of hard to define exactly where they start. But regardless of whether you count the Amazon or the Nile as the longest river, far and away the Amazon River, or the Amazon basin as a whole, is the largest river in terms of the total discharge. That is the total amount of water that it dumps out into the ocean every year. So to give a comparison, the average discharge measured in cubic meter per second of the Nile River, and this discharges into the Mediterranean Sea, obviously, flowing from south to north, is about 3,000 cubic meters per second, which is a lot. 3,000 cubic meters is a lot of water, and of course the Nile is a very important river, particularly for that region of the world. But the Nile is actually quite small compared to many of the other major rivers in the world. So the Mississippi River, for example, has an average discharge of about 17,000 cubic meters per second, several times that of the Nile. The Mississippi discharges obviously out to the south in the Gulf of Mexico. And the drainage basin for the Mississippi comprises a large proportion of the continental United States, including much of the Midwest regions and surrounding southern states. So to use those as sort of points of comparison, Nile about 3,000 cubic meters per second, Mississippi about 17,000 cubic meters per second. The Amazon River and its various tributaries discharges about 210,000 cubic meters per second. So that's more than 10 times the Mississippi River. In fact, I think I read somewhere that the Amazon discharges about the same amount as the next 6 or 7 largest rivers combined. So it's pretty much impossible to overestimate how enormous the Amazon River is in terms of its discharge, the total amount of water that's there. Its drainage basin is also the largest in terms of the area. The Mississippi's, again as a point of comparison, the Mississippi's drainage area is about 3.2 million square kilometers, a large fraction of the continental United States. But that's less than half of the drainage basin area of the Amazon, which is over 7 million square kilometers, and it covers a large portion of western Brazil, as well as surrounding areas of Colombia, Peru, Venezuela, and other countries. So aside from these few rivers that I've talked about, the second biggest river basin by drainage area, and I think also second largest by discharge, is the Congo River in Africa. The basin there covers a large portion of the country by the name of the Democratic Republic of the Congo. And the Congo region runs through the surrounding rainforest areas that are located there. Other major river basins in Africa are the Niger River Basin, which is sort of just to the south of the Sahara in Western Africa, and the Lake Chad Basin, which actually drains into Lake Chad, which is a saltwater river, I believe. In the Middle East, the major river basin is that of the Euphrates and the Tigris rivers, which flow out into the Persian Gulf. That region there and those rivers was essentially sort of the cradle of early civilization in that region. That along with the Nile Valley. In fact, many of the early civilizations were centered around river valleys. Another example of that is the Indus River Valley, which is in western India, Pakistan. Flows out into the Indian Ocean. Also to the east of the Indian subcontinent, the Ganges and Brahmaputra rivers, which flow out also into the Indian Ocean. In Australia, there aren't a whole lot of major rivers in Australia, being a pretty dry continent, but one of the major ones in the southeast is the Murray-Darling River Basin, which covers a large portion of Victoria and New South Wales, those areas there. In China, the major rivers include the Yangtze River down sort of to the south and the Yellow River up in the north, both of which drain out to the east. In Europe, the two major rivers, as you may be aware, are the Rhine, which drains out into the North Sea, and the Danube, which discharges into the Black Sea, and its drainage area covers a large portion of sort of southeastern Europe. There are a number of large river basins located in Russia. The most well-known of these is probably the Volga River, which is generally thought to be the longest river in Europe. Of course, it depends exactly where you define Europe, but usually this is considered to be part of Europe, and it discharges out into the Caspian Sea down in the south. To the east of the Volga River is the Ob, which also has a large drainage basin in sort of western Siberia, and then to the east of that again you've got the Yangtze River and the Lena River and the Kolyma River and the Amur River. So I'm not quite sure how to pronounce all of those, but these are all large rivers with very large drainage basins sort of progressively situated further east in Siberia or eastern Russia. So there are, of course, many other major rivers and river basins in the world. I've only mentioned a few of them. But one final point is that I've discussed the area or the drainage area of river basins, but what I didn't say is what determines the extent of the drainage area. And in general, the mountain ridges or the high point between valleys is what determines whether water will flow into one drainage basin or another. So, for example, the Rocky Mountains to the west and the Appalachians to the east define the boundaries, at least in some areas, of the Mississippi drainage basin in the United States. So usually there are surrounding mountain regions, or at least high points of land, that define the extent of drainage basin. Although that's not always the case, there are other factors as well. But that's a common cause of the boundaries of drainage basins. Okay, so for the concluding part of the episode, I wanted to move away from mountains and rivers and talk about some of the major biomes. So these are sort of geographic regions of the Earth. A biome is defined as a large ecological area where plants and animals have common characteristics suited to the particular environmental conditions there. Biomes are therefore defined based on the flora and fauna that are found in that region. However, as I mentioned before, these are to a large extent shaped by and correlate with the particularly temperature and annual rainfall in those regions. So there's, if you look at a map of biomes defined by flora and fauna, if you look then at a map of, say, the Köppen climate classification system, which is defined mostly by rainfall and temperature, and also, on the third hand, if you look at a map of the different soil classification systems that define the different types of soils in different regions of the globe, there's a reasonably good correlation between the three of them. Not perfect, and you have to look at all of them at a sort of similar level of detail, obviously, because you can get into lots of detail when you have dozens and dozens of different classifications, or as we'll look at a coarser grain of analysis where you have only maybe a dozen total, 10 or so different classification zones. But there's a fairly close relationship between these, and so here I want to focus on biomes, but bear in mind that there are lots of commonalities within these regions and distinctions between the different ones as determined by the rainfall, the temperature, the type of plants and animals that live there, the type of soil that's there, and other factors like that. So that's why I think it's useful to have some understanding of these regions. Regions of the planet Earth, because they are sort of distinct from each other in relevantly consistent ways. And the first one of these biomes that we'll talk about are probably the most famous, tropical rainforests. Tropical rainforests are characterized by being hot and wet. They're found around the tropics, hence their name, so around the equator, sort of a bit north and a bit south of that. I'll also mention that before I get into detailed descriptions of where these different regions are located, every single map that I've looked at, and I've looked at quite a number of different maps of these biomes. Every single one that I've looked at is different in exactly where they draw the boundaries between different biomes. And partly that's because there's no sort of standard classification for these things. There are many, many different ways of doing it. So I am going to discuss in sort of a general way where these biomes are usually said to extend. And I'm not going to sort of get too bogged down in the nitty-gritty of exactly where the boundaries are. Most of them are pretty similar in terms of the overall distribution. There are some differences here and there. Some regions are harder to classify. India particularly seems to differ a lot map to map as to exactly what type of climactic region or biome it's classified to. But nevertheless, I think that the description I provide here will provide a pretty good sort of general overview about which regions of the world sort of correspond to which general type of biome. Okay, so that caveat out of the way, back to talking about tropical rainforests. Tropical rainforests are found around the tropics near the equator. So the largest of them by far is the Amazon rainforest, which is fairly close in terms of location to the Amazon drainage basin. So it's connected directly to the Amazon River. Essentially, the reason the Amazon River has such a large discharge is because of all of the rainfall that occurs in that area. And the rainfall also supports the existence of the rainforests. So the Amazonian rainforest is essentially located in western Brazil and also eastern Peru and surrounding areas of Colombia and other countries in South America. Tropical rainforest is also found in the Congo, so that's essentially Central Africa and some of the surrounding countries there, like Cameroon. It's this rainforest which is the one that sort of Tarzan is supposed to have lived in. Rainforest is also sometimes called the jungle. That word does not have a precise botanical or geographic meaning, but at any rate, it might help you sort of correlate places with word terms you've heard before. There are also lots of large regions of tropical rainforest in Southeast Asia, so sort of Vietnam, Malaysia, Thailand, and all throughout Indonesia and also the Philippines, and some parts of southern India and Sri Lanka as well. In some of these regions, the actual rainforest has been cut down to varying extents in the past decades. I mean, all of these regions suffer to varying extents from deforestation, but nevertheless, there are still very large regions of rainforest found throughout these areas. So all of these regions are in the tropics and more or less aligned with the equator. They all experience very high rainfall and consistently high temperatures. Rainforests are characterized by very lush growth, so trees that form a canopy, so cover the ground completely, so that actually when you're standing in a rainforest, there's actually not that much vegetation on the ground itself, because the small shrubs and other plants like that can't get very much sunlight. I think only about 2% of sunlight reaches the ground, or the bottommost layer, the forest floor as it's called, in rainforest, because almost all of it is taken up by higher levels. Particularly the canopy, which is the top covering of the leaves of the taller trees. So the forest floor itself is sparser vegetation-wise and tends to be inhabited by plants that are adapted to low levels of light. The understory connects the forest floor and the canopy, so it's sort of like the middle region, and it's home to many birds, small mammals, and insects, reptiles, and so on. And vegetation at that layer is generally consists of shade-tolerant shrubs, herbs, and smaller trees. Also vines that climb onto the trees and are able to capture some of the sunlight. Rainforests are generally made up of tall, broad-leaved evergreen trees, so that is trees that do not lose their leaves during winter. So they're typically the dominant plants, and the densest areas of biodiversity are found in the canopy, so many different animals live there. As a whole, rainforests are incredibly biodiverse. They're easily the most biodiverse regions or biomes in the world. It's thought that something around half, I mean, we don't really know, maybe half to two-thirds of all biotic species, so like all species, are indigenous to rainforests, which is pretty insane if you think about rainforests as not covering anything like half of the land area of Earth. Interestingly, despite the fact of the huge degree of biodiversity and the very lush plant growth, especially the trees, rainforest soils are actually poor. That is, they're not rich in nutrients. And the big reason for that is because the heavy rainfall leaches soluble nutrients out of the soil, and what's left is retained in the vegetation. So this actually contributes to deforestation, because when regions of rainforest are cut down to serve as, say, pasture or cropland, often a technique called slash and burn agriculture is used. And this essentially involves cutting down the trees and burning all the vegetation, which releases the nutrients, or some nutrients that were stored in all of that vegetation. And that serves to provide nutrients to the soil for a few years. But after that's depleted, the soil itself doesn't retain. It is, as I said, fairly impoverished in terms of nutrients, because it's all been leached away with a very heavy rainfall. And so after a few years, the land becomes relatively infertile, and then there's a need to sort of move on and cut down and burn a new region of rainforest, and so the sort of cycle of deforestation continues. That's been a problem, especially in the Amazon. So tropical rainforests are certainly very interesting, biologically speaking, and very important in sort of ecosystem perspective, especially because just so many species are found there, and they're so biologically rich. A similar biome, which I won't talk about in detail, is sometimes distinguished from tropical rainforest, called a seasonal tropical forest. It's more or less the same as a tropical rainforest, but it has a little bit less rainfall and sometimes has deciduous trees, so trees losing their leaves for parts of the year, and is typically a bit less biodiverse than the rainforest proper. So it's basically just like a sort of a lesser version of the rainforest. And usually, sort of, if you see maps of these biomes, there's the tropical rainforest proper, and then there's some areas around it that are seasonal tropical forests, which is similar to rainforest, but not quite as lush and not quite as heavy rainfall. So that's the first biome that I wanted to talk about, the tropical rainforest. That's one that many people have heard of. Another important biome that many people have also heard of is the tropical savanna. These are grasslands that are located in semi-arid to semi-humid regions of subtropical and tropical latitudes. So a crude way of putting this is that many of these, as I said before, many of these biomes are distinguished by the amount of rainfall that they receive and their average temperatures. So if you think of the tropics, particularly along the equator, as receiving a lot of sunlight and a lot of rainfall, these are mostly within rainforest biomes or seasonal tropical forest biomes. As you move somewhat further away from the equator, in many cases, you have a decrease in rainfall, but still relatively high temperatures. And so these regions, in many cases, form the tropical savanna. This is essentially what happens when you have hot regions, but without as much rainfall, with intermediate amounts of rainfall. The savanna is defined by large grasslands with isolated shrubs and trees. So exactly how to define a savanna is a bit contested, but the basic idea is that the trees do not grow close enough together to form a canopy, so they don't the leaves of the different trees don't connect or join to each other so that they block out the light over large areas of land. So it's not a rainforest or a temperate forest, which we'll talk about later, but there are trees, usually, they just spread thinner than that. Essentially, there's not enough water for as many trees to grow as in a tropical rainforest area. So savanna is basically grassland with isolated trees and shrubs. And these areas are also typically very rich, especially in Africa, where we associate the savanna with big game animals, like hippopotamus and elephants and lions and all sorts of things like that. These live in the savanna. Savanna has variable rainfall year to year, so unlike the rainforest, which has heavy rainfall pretty much all the time every year, savannas have much more variable rainfall. So some years they may get quite a lot, some other years not very much, and therefore they're subject to extensive wildfires during the dry season. That's another distinguishing feature of savannas, that during the wet season the grass will tend to grow tall and lush. During the dry season it will sort of die off and become sparser and flammable. Rainforests don't have that seasonality really at all. So tropical savanna, as I mentioned, cover large areas of Africa and also some areas south and east of the Amazon rainforest. Also some areas in Australia, sort of surrounding the proper desert region. Some areas in India are classified as tropical savanna as well. But as I said, by far the largest regions of savanna in the world are in Africa. Pretty much the majority of the African continent that's not either the central part that's around the Congo, the tropical rainforest part, or the Sahara in the north, or some of the more temperate regions down in South Africa. Pretty much all the rest is more or less savanna of one form or another. So this includes the large savanna regions of Kenya and Tanzania and other areas that are sort of most commonly thought of in terms of the savanna. But the savanna is a very large biome in Africa and is sort of one of the defining features of that continent. So moving on from the savanna to the next biome that we'll talk about, which is desert. Now everyone's heard of desert. The technical definition of desert is just that it's characterized by low rainfall. So if you recall, we started off at the equator with very high rainfall in the rainforest. We moved generally north and south a bit to regions that we call the savanna because they have less rainfall, still fairly warm. If we move further away from the equator again, in many parts of the world, we come to desert regions, which have even less rainfall, but are still generally quite hot. Now, deserts don't have to be hot. Antarctica is usually thought of as a cold desert because it doesn't have very much rainfall or precipitation, but is obviously not hot. It's very cold. But most of the deserts in the world are hot. And as I said, the characteristic defining feature is that they have very low rainfall. So as a result, they have minimal vegetation coverage. Usually very few trees, and some degree of coverage of grasses and shrubs. Often when people think of deserts, they think of sandy deserts, so those big sand dunes that you think of in, say, Egypt, around the pyramids and so on. And deserts can look like that, but they don't have to. Many regions of the world do not have sandy deserts, but have deserts that are just exposed rock, or where there's sort of a small covering of not very nutrient-rich soil where you'll have some sort of sparse shrubs or grass growing, but not very much. So overall, there's not much vegetation in deserts because there isn't enough moisture to support it. And as a result, there's not as much animal life as well, although there is a lot more animal life in deserts than most people think. In particular, large numbers of insects, reptiles, and small mammals typically live there. They're often quiet during the day because of the hot temperatures, so they're not as active as wildlife often are in the savanna, but nevertheless they are there. Deserts are often quite fragile ecosystems, and they're particularly sensitive to soil disturbance or overgrazing because there's often little vegetation to begin with. Erosion can be a big problem in deserts, so the small amount of grass or shrub cover that does exist is often important for keeping the topsoil in place. That can easily be overgrazed by cattle, for example, or other animals, which then leads to loss of topsoil, so soil disturbances, and this can then lead to a process of desertification, where the desert actually extends out. That's happening in the Sahara at the moment, essentially. The Sahara Desert grows at a certain rate every year because of the desertification of surrounding areas. The most famous and by far the largest desert outside of Antarctica is, of course, the Sahara Desert, which is in northern Africa. The Arabian Desert in the Arabian Peninsula is also a very large desert. Deserts also cover large portions of the Australian continent, especially in the sort of middle and western areas of the Australian continent. In Australia, the more northern regions are kind of a bit more tropical, a bit more savanna, and there are even some rainforest areas in parts of Queensland, which is sort of the northeastern area. But the majority of sort of the centre area of the continent is desert. There aren't as many deserts in South America, although there are some, especially on the Pacific coast. In North America, there are large deserts extending from sort of central Mexico up through western regions of the United States. In Asia, deserts cover large regions of Central Asia, so up around Iran, Pakistan, Afghanistan, and up through east of the Caspian Sea and over also onto Mongolia. Many people have heard of the Gobi Desert, which is located in Central Asia as well, which is a very large desert area. Actually, it's quite a large fraction of the Earth's land surface is covered by deserts. The next biome that I'll talk about is a much smaller one. So the previous few that we've talked about, tropical rainforests, savanna, deserts account for quite a lot of the surface area of the planet. In fact, together they account for almost all of Africa and a large part of Australia as well. This one, the Mediterranean biome, or Mediterranean woodland and shrub, as it's sometimes called, is mostly only found, not very surprisingly, around the Mediterranean Sea, particularly in Spain, Italy, Greece, the coastal regions of Palestine and Turkey, and also northern Africa. So that's just north of the Sahara Desert, particularly in Algeria and Tunisia. There are some other regions of the world that are characterized by this climate as well. Small parts of southern Africa, parts of southern Australia, and parts of southern California as well. But the largest areas are found around the Mediterranean. The Mediterranean woodland and shrub biome is generally characterized by dry summers and rainy winters. So the summers are typically hot in more inland locations, although they can be cooler near the sea areas, and generally Mediterranean is characterized by, most of these areas are fairly coastal, much closer to the coast than, say, a lot of the desert regions or tropical rainforest regions are. Vegetation ranges quite a lot from forests through to woodlands, savannas, shrublands, and grass. So there's quite a lot of variability in Mediterranean areas as to the type of landscapes. Mosaic habitats are actually quite common, where there's different types of vegetation types intermixed with each other. Really what distinguishes the Mediterranean biome is the very dry, hot summers that are prone to wildfires. And as a result, many of the plants in these areas are adapted to those conditions, so that they actually have seeds that will germinate as a result of being exposed to high temperatures of fire. So there are many sort of adaptations of nutrient cycles and vegetation cyclings adapted to cyclical bouts of destruction by fire in these areas. So Australia and Californian bushfires are particularly well-known examples of this. Moving on then from the Mediterranean biome to the temperate grassland biome. Now, if you recall my discussion a bit earlier about geographic climactic regions, these were divided into very coarsely into the tropical or torrid regions, the temperate regions, and the frigid regions. So the tropical rainforests, savanna, and deserts are largely associated with the tropical or the torrid regions. All of these have in common is that they're generally fairly warm, and what differentiates them is the amount of rainfall they get. So rainforests a lot, savanna intermediate amount, deserts not very much, but all of them are quite warm most of the time, and they're generally found more or less in the tropics. The Mediterranean biome, as I said, is a bit of a special case, mostly around the Mediterranean and a few other coastal areas. The next major biome is the first one that falls in temperate regions. So this is further away from the tropics, and this is temperate grassland. So temperate grasslands cover quite a large area of many parts of the world, especially many parts of the world, including most of what I discussed before, the Mississippi Basin, so essentially the central third of the United States. Much of that is grassland. Southern South America, not the Andes on the west coast, but the area to the east of that, which is called Patagonia. A lot of that is temperate grassland. Large areas of Central Asia are also temperate grassland. Large parts of Central Asia are covered by desert or mountainous regions, but basically if it's not either desert or mountains, it's probably temperate grassland. So this includes large areas extending from the Ukraine to the northeast through that region there, right across just to the south of Siberia over to the edges of China. Also, significant areas in southeastern Australia around Victoria, New South Wales, corresponding to the Murray-Darling River Basin, are also temperate grassland. Temperate grasslands are more commonly known by the names either a prairie or steppes. So prairie usually refers to temperate grasslands that have quite lush, rich grass, quite thick tall grass, whereas steppes are usually associated with shorter grasslands that occur in areas that are semi-arid, so that have less rainfall. So usually in the Central Asian cases, you talk about the steppe because the grass is a bit shorter there and there's a bit less rainfall. Usually in the case of the US, the areas around the Mississippi Basin, that's the word the prairie is more often used. But the climate and types of vegetation are comparable in at least a lot of these regions. As should be obvious, the major vegetation coverage in these areas is grassland. There are, of course, some trees and shrubs, but predominantly it's covered by grasses. But generally rainfall is insufficient for them to grow very thick, so they don't form a canopy. So in a loose sense, temperate grasslands are somewhat analogous to tropical savanna, although you shouldn't take that analogy too far. The main difference is that they have intermediate amounts of rainfall, so they're not deserts, but they don't have enough to form forests, and they're also a fair bit cooler than tropical savanna regions. Related to temperate grasslands are one of the other major temperate biomes, which is the temperate forest. So these aren't rainforests because the rainfall is a lot less than it is in the tropical regions. They're also temperate because the temperatures are quite a bit lower. But in other respects, they're somewhat analogous to rainforests in that there is a canopy that forms a continuous covering of foliage by the trees. In this case, though, generally broadleaf deciduous trees, not the evergreen trees found in rainforests. Temperate forests generally have distinctive warm and cool seasons, so that's why many of them are deciduous, with losing their leaves in the colder months of the year, although that's not always the case. Common trees in the northern hemisphere include oaks, beeches, maples, and birches, so many of the sort of common trees that many people are familiar with in at least Western countries are native to these temperate forest areas. There are also coniferous trees, so these are the ones that have much thinner sort of spindly leaves and more often than not evergreen, so they don't lose their leaves. These include pines, firs, and spruces. So they're also found in temperate forests areas as well. In more southern areas, the major genre of trees are the eucalyptus trees, so they're found particularly in Australia. Temperate forest areas cover large regions of the temperate parts of the globe, basically most of those areas that aren't covered by either deserts, temperate grassland. So nearly all of continental Europe, outside of the parts that are Mediterranean and outside of the very northern parts in Scandinavia and Russia, but nearly all of the rest of continental Europe is covered by a region of temperate forest. Most of the eastern area of the continental United States is covered by the temperate forest biome. Pretty much everything east of the Mississippi. Large areas of northeastern China, as well as Korea, Japan, and also many parts of sort of Turkey and the Caucasus around there, covered by temperate forest, and the east coast of Australia and New Zealand and parts of South America. In the case of temperate forests, it's important to understand that there's an analogy between temperate forests and tropical rainforests in another respect, and that is of deforestation. So particularly because temperate forest regions have been historically have been parts of the world inhabited by large, powerful civilizations, so that includes Europe, parts of the Middle East, China, Japan, and more recently the United States. Large areas of temperate forest have been cut down. In fact, almost all of the temperate forest that once covered mainland continental Europe and also Britain has now been cut down. Of course, there are still areas of forest there, but in terms of, but once upon a time, essentially the entire continent was covered by these forests. Now most of it is cropland or urban area. Likewise with the eastern United States, nearly all of that area used to be covered by temperate forest, and China and Japan similarly. So the important thing is that the biomes here are defined not by contemporary vegetation, but sort of by the traditional endemic vegetation, which still is found in these regions. But the fact that most areas in the temperate forest biome don't actually have forests covering them anymore doesn't change the fact that they're still classified in this biome. Now we leave the two main temperate biomes, the grassland and the forests, and move further north to discuss the two frigid climactic or geographic area biomes. The first, which is the more southerly of the two, is called boreal forest or taiga. That's spelled T-A-I-G-A. Now, this is a biome characterized basically by coniferous forests, so mostly pines, spruces, and larches. There are some of these in the temperate forest as well, but in the boreal forest, it's pretty much only these trees. Most of them are evergreens, so they'll keep their leaves throughout the year, even though they are very cold. There is not that much rainfall, though enough to maintain the forested regions. Most of the rain falls during the summer months, but there's also snow during winter months. The harshness of the climate, so again very cold in these areas, means that the range of animals is relatively small, and particularly reptiles and amphibians aren't really able to live there very much because of the cold temperatures. Birds do live there during summer, but tend to migrate south into warmer climates during the winter. The massive forests of pines in Siberia are the largest example of taiga, and these extend really right across the northern areas of Asia and also parts of northeastern Europe into Scandinavia as well. Much of Canada is also the more sort of central and northern parts of Canada, and even parts of the very northern areas of the United States are covered by boreal forest. So the boreal forest tends to be one of the most distinctive biomes in the sense that, unlike, say, the savanna or temperate forests, which tend to vary quite a lot, or even Mediterranean, say, the boreal forest tends to be very monotonous. It just goes on and on and on. Pine trees, more pine trees, to put it crudely. Unlike all of the other biomes that we've discussed so far as I'm aware, boreal forests or taiga only exist in the northern hemisphere. There may be some very small regions down south that I'm not aware of, but predominantly the right combination of rainfall and cold temperatures only exists in the northern latitudes, whereas essentially in the southern hemisphere in those regions there's just ocean. The final biome that I'm going to talk about today is even further north than the taiga or boreal forest. And I mean, the boreal forest is cold enough as it is. What happens when you go even further north than that into the frigid region? Well, in this biome, you get to the tundra. Now, the difference between the boreal forest and tundra is essentially that trees can't grow in the tundra because temperatures are so low and available water is even lower than in the boreal forest that trees can't grow here. So essentially, if you go north of the temperate forest or grasslands that exists in Europe and sort of many parts of Central Asia, or the non-desert parts of it, if you go north of those regions, you'll get to the boreal forest, which extend for a long, long ways. And if you go far enough north, you'll eventually reach the tundra, where the trees stop. So there's often a sharp demarcation, or relatively sharp demarcation, where trees can't grow anymore, which is called the tree line. And north of that, or sometimes further up the mountainside than that, if it's in mountain areas, is tundra. Basically, the vegetation is small shrubs, grasses, and a lot of mosses and lichens. You may have a few scattered trees, but for the most part, trees can't grow there. Technically, the word tundra usually refers only to the areas where the subsoil, so just below the surface, the topsoil on the surface, is permafrost. That is permanently frozen. The water in these regions is permanently frozen. Although sometimes it's applied a bit more broadly than that to encompass some other surrounding areas that don't have permafrost. Some areas of permafrost have actually been melting in recent years, partly due to global warming, and this can lead to some interesting phenomena, including drunken trees, where the trees that have grown in the permafrost, when the permafrost melts, they sort of lose their support and they not fall over, but lean over at varying sort of crazy angles, and it looks like the trees have sort of been drinking too much. This is a sort of interesting thing to see. Tundra pretty much only exists in the very northern regions of Siberia, so the northern fringes of Asia, parts of northern Scandinavia, and northern Canada and Greenland. There's not a great deal in the way of diversity of wildlife in the tundra regions, although there are some plants and animals and indeed peoples who live there, but it's not particularly rich or productive area because of the extreme cold. And if you go even further north of the tundra, or in the case of Greenland, further inland, because the tundra is more on the coastal areas, you essentially just get ice, where there's not really any biome at all. Very little lives there, apart from maybe some polar bears and birds might fly around a bit. Yeah, to the north of the tundra, around the North Pole and central Greenland ice sheet, is just ice and snow. So there's not really much in the way of a biome there, and essentially no vegetation. So, that concludes the tour of the world biomes, and if you combine all of the biomes that I've talked about today, the tropical rainforest, tropical savanna and deserts, the Mediterranean woodland and shrub region, temperate grasslands and temperate forests, and boreal forests or taiga, and the tundra, if you put all them together, they comprise the majority of, the large majority, probably I'd say more than 90% of all of the land area on Earth can be more or less classified into one of these areas. There's another one called montane, which essentially refers to mountainous areas, are often distinctive from any of the more low-lying regions. The majority of montane regions are found either in the Alps or in the Tibetan plateau north of the Himalayas. For the most part, the ones we've talked about cover the majority of the Earth's surface, so having an understanding of how rainfall and temperature shape the types of plants and animals that are endemic to a region of the world, and also how that further interacts with the mountain regions that exist in the area and the major rivers and drainage basins to shape the local geography and biomes and the biogeography of the large continental regions that then all combine together and make up the planet Earth, I think is a useful thing to have an overall picture of. And so in future episodes, we will talk in more detail about some of the mechanisms that lead to some of these results, including the rotation of the planet Earth and the varying amounts of solar radiation that different parts of the world get, flows of heat around the atmosphere and the ocean, and some of the geologic processes as well that lead to the movement of tectonic plates and creation of mountains and other phenomena such as that. So, hopefully you found this episode interesting. If so, perhaps you would be so kind as to give the show a favourable review on iTunes or the aggregator of your choice. You can also go onto Facebook and find their Science of Everything podcast page and give that a like, which helps to spread the word of the show, and also is a good way for you to find out when new episodes have been released, and sometimes I put up images to accompany the episodes that you can see there. If you would like to contact me with suggestions, feedback, questions, or anything else, you can send me an email. My address is fods12@gmail.com. That's FODS12@gmail.com. Thanks for listening, and I'll talk to you next time.